Okay, here we go. Unit 3, exam study guide. So figure F, here's F right here, is a scaled copy of figure E. First thing is F is smaller than E. So we know that AB equals 6, CD equals 3, XY equals 4, and ZW equals A. We have to select all the true equations. Okay. So the key thing you need to know on this is that corresponding sides are in the same ratio. So what you could say is 6 over 4 equals 3 over A. So you could say 6 over 4 equals 3 over A. Now, what I would encourage you to do then is then cross multiply. And solve for A. So 3 times 4, 4 times 3 equals 6 times A. So 12 equals 6A. Divide both sides by 6. A equals 12 over 6. So 2. A equals 2. All right, so we now know that A equals 2. Now, what I would recommend that you do is then plug in A equals 2 in each of these. So, does 6 over 3 equal 4 over 2? Does 6 over 4 equal 3 over 2? Does 3 over 4 equal 6 over 2? 6 over 3 equal 2 over 4. 6 over 4 equal 2 over 3. And finally, does 3 over 4 equal 2 over 6? So once you solve for A, you can then just plug in A. So 6 over 3 is 6 divided by 3 equals 2. 4 divided by 2 equals 2. So this one is true. 6 divided by 4 is 1.5. 3 divided by 2 is also 1.5. This one is true. Does 3 over 4 equal 6 divided by 2? No way, because 6 divided by 2 equals 3. So 3/4 does not equal 3. Does 6 over 3 equal 2 over 4? No way, because 6 over 3 equals 2. 2 over 4 equals 1/2. Now, does 6 over 4 bigger than 1 equal 2 over 3 less than 1? No. And finally, does 3 over 4 equal 2 over 6? No. So for this one, it's just A and B. Key one is corresponding sides are in the same ratio. You cross multiply, solve for A. You get A equals 2. Last step is plug in A equals 2 for A through F. That's what I would do on this one. And then evaluate if true. Okay, that was the first question. Here's your second. Quadrilateral ABCD is similar to quadrilateral A prime, B prime, C prime, D prime. Okay? Select all statements that must be true. Okay, so if you put A prime, B prime over AB, that will equal A prime, C prime over AC, because we're comparing corresponding sides. So this one's true. AD divided by A prime D prime, BC divided by B prime C prime. So again, comparing corresponding sides, they're in the right order. This one's true. This is where it gets a little off. BD over B prime D prime, up here you're going to have to put, these are going to have to be switched if this were true. This should say CD over C prime D prime, but it does not. AB over CD, this is good as long as A prime B prime over C prime D prime, so that one's good. BC over A prime D prime, can it equal B prime C? No, because they're switched. So your answer is ABD. Okay, here is a triangle ABC. So there's A, B, C. M is 2/3 of the way from A to B. N is 2/3 of the way from A to C. So what we're gonna say here is what can you say about segment MN compared to BC? So if this is 2/3 of this, and this is 2/3 of this, then that means that the corresponding sides are in proportion. So what you can say is that because the corresponding sides are in proportion, you can now say that MN is parallel to BC because in similar triangles, lines are dilated to parallel lines when the center of dilation, in this case A, is off the line. That's the first thing you can say. So MN and BC are going to be parallel because in similar triangles, lines are dilated to parallel lines when the center is off the line. You'll also be able to say, because this is 2/3 of this and this is 2/3 of this, you'll also be able to say that MN is 2/3 of BC. So you could say MN is 2/3 BC. Why? Because corresponding sides are in the same proportion. Okay, two things you could say, 1 and 2. All right, what do you notice? What do you wonder? So I noticed that 3 plus 9 is 12. So AB must be 12. I noticed that 5 plus 15 is 20. So let's look at the smallest triangle, ADE. So 3 times 4 equals 12. 5 times 4 equals 20. And 4 times 4 equals 16. So I notice all corresponding sides are in proportion. You could say triangle ADE is similar to triangle ABC. You could also say that the scale factor from the small triangle ADE to the big ABC is 4. Okay, what is the length of segment DF? So we've got to figure out DF. This one I would recommend using color. So let's color in the 68 in green. There's your 68. All right, let's color in the 44 in orange. Now this angle we'll figure out with a calculator. So 68 plus 44 is 112, which means, okay, we've got another 68 right here, meaning this one's also 68. That makes this one kind of easy because you got 2 green angles now. So this will be easy to visualize. All right, so you see these 2 green 68s and these 2 green 68s? That means that this side AC, the corresponding side would be ED. So we've got a 6 times the scale factor equals 18, right? Because that's our formula, A times scale factor equals A prime. We've been using that formula a ton. This is your big formula. So divide by 6, divide by 6, these cancel out. You find out that your scale factor equals 3, 18 divided by 6. So 6 times 3 gives you 18. Now we're trying to figure out DF, which is right here, DF. So you're going to find that the similar side, well, first of all, these are the same. So this side is going to be the same as this. And this side is going to be the same as this. You're already given this 8 right here, so that means that's 8. So how do I know that? Well, that's the definition of isosceles triangles. So in isosceles triangles, if the base angles are the same, then the sides opposite them are also the same. All right, so we know that from 68 to 44, 68 to 44 on this triangle is 8. This one we don't know yet. But you just use this formula again. So A times scale factor equals a prime. So for this one, we know our original is 8, our scale factor is 3. That's going to equal df. So what is 8 times 3? It's 24. So df equals 24. You just figure that out by getting the scale factor and then using this one that you're already given to then figure out that 8 times 3 equals 24. This one's also going to be 24. You also need to know about isosceles triangles. Okay. Next up, number 4. What is the length of segment DF again? So here we go. Green, green, orange, orange. Now we also know this one, again, we just did it. It's going to be 68. That's going to be 68. If you want to use green again, that'll help you. Color coding is so easy. So green, green. You got a 9 given and a 27 given. So 9 times your scale factor will equal 27. Divide by 9, divide by 9. Your scale factor equals 3. So going from the small to the big, it gets 3 times as big. How do we know that? Well, because AC, the side length in between the two green angles, is 9. And ED, the side length between the other two green angles, is 27. And 9 times 3 equals 27. Okay, so our scale factor is 3. Now we got to figure out DF right here, which is green to orange. Now, because they gave us 12, you can just go 12 times your scale factor equals DF. Now, we don't know DF yet, but we do know our scale factor is 3. So you just go 12 times 3 equals DF. 36 equals DF. So the one you want is, let's see. Okay, dilate triangle FGH using center C and a scale factor of 3. Okay. Yeah, you can use inches or millimeters. So this one is, so C to F is 1 centimeter. So F prime is going to be right here. I'm just multiplying every distance I get by 3. So C to G is 1.12. It's right in between 2 and 3, so 1.25. So 1.25 times 3 equals 3.75. So 3.75 is going to be right here. That's going to be G prime. And then last but not least, go C to H. So measure C to H, which is 1.6. So you just go over here, 1.6 times 3 equals 4.8. There's your 4.8. And that's going to be H prime. Just got to connect the dots and you're done. Okay. Go. Be right back. Look at that stack of study guides. Oh. All right. Okay, we are cooking. All right. Another dilation. We gotta dilate triangle FEG using center C and scale factors of 1/2 and 2. All right, no worries. So you just measure C to every single point. So C to G is 1.1. So if your scale factor is 1/2, everything gets divided by 2. So 1.1 divided by 2 is 0.55. So there's 0.55. Okay, let's go C to F. C to F is 2.4, so you're gonna need 1.2. And then C to E is 0.95. So you go 0.95 either times 0.5 or divided by 2. So 0.475, 0.1234, almost to there. Okay, so there's the 3 points you need for the smaller triangle. Okay, so there's your first one. A little green for that one. Call this E prime. Call this G prime. We'll call this F prime. The second one we're going to do in orange. And you just need to measure from C to E. C to E is, I think we said it was 0.95. So 0.95 times 2. 1.9 is right there. And you go C to G again. 1.1. Scale factor of 2, so we're going to 2.2. And last but not least, C to F is 2.4, so we're going 4.8 there. So here we go. This is going to be E. We'll call it double prime, G double prime, F double prime. Connect our dots, call it a day. That's how you do dilations. Just measure from your center to each vertex, multiply those distances by your scale factor, and then measure them out, mark your points, label your points. Good to go. Okay, select all figures which are similar to parallelogram P. So here's parallelogram P. So similarity, you need to know the definition of similar. So all angles, all corresponding angles are congruent. All sides in the same proportion. So all corresponding angles congruent and all sides in the same proportion. So I'm first going to look for the angles 50, 130, 50, 130. So 50, 130, 50, 130. Okay, we're good there. 5, 5, they're all 5 to 5. So that one's good. So figure A is similar. Also happens to be congruent. Okay. 50, 130, 50, 130. Okay. So we got all corresponding angles congruent. And each one of these 5s goes to a 3. So that one's also similar. All the sides are in the same proportion. All corresponding angles congruent. I automatically know C is out because the angles are not the same. And I automatically know D is out because even though the angles correspond, all these sides are 5, the same length, and these are not the same length. So there's no chance the sides could be in the same proportion. And then figure E is just obviously not. I mean, you've got these numbered angles, which are, I suppose, are the same, 130s and 50s, but we don't even have the same shape figure. This is a trapezoid and this is a rhombus. So figure A and B is your answer on that one. All right, next one. This is a tough problem. It's on the test. Okay, which triangles are similar to triangle AED? So AED, gonna help you with some coloring. They want to know which triangles are similar to AED. Okay. How are we gonna do that? Well, I've got some ideas. Okay, so this one we're going to use a lot of things we know. So we are given that this one is 90. So for this problem, you've got to find missing angles. And go slow on this. Just use what you know. Okay, so I know that this whole line is 180. So like from here all the way here, that's a semicircle, right? So that's 180. You got 53, 90 plus this one right here. So this angle is gonna be, so you got 90 plus 53, it's 143. And the whole thing is 180, so what's the difference? Well, that makes this one 37. There's 37, okay. Now this is a rectangle, meaning that these corner angles are 90. So that 90 plus 53 plus, again, 37, because all three angles have to add up to 180 degrees. That's the triangle sum theorem. Okay. So 90 plus 37 plus this one's 53 right here. Meaning that this is 37. Got a 90 here. This little one's going to be 53. 37 plus 53 plus 90 equals 180. You know this that this plus this, well, I'm going to actually use something else. Parallel line to that parallel line, transversal, alternate interior angles congruent. That means this one's 53. So, in 1, 2, 3, 4, the angles are all 90, 53, and 37 degrees in all four smaller triangles. So all four smaller triangles are the same shape. Why? Because they all have 90, 53, and 37. You could use angle-angle triangle similarity as well. So all four smaller triangles are similar to triangle AED. Now, the hard part is getting the names. So we're going to say triangle AED. We're going to write this 4 times. You got to get the names of these triangles correct. And don't forget, order matters. So A is 37, E is 90, and D is 53. So let's look at this first one. 37, so we're going to call this one E. And you got to go to the 90, B, and then do the 53, A. So this one is done. Now let's look at this one. Since we're starting with A, which is 37, we're going to do this medium one. So then you got to start with 37 again. E was 90. So let's go to F. That's 90. And then end at the 53, right? So A, F, E. So this little one's done. Now let's go to this one right here. Start with the 37. That's E. Triangle E. And then we go to the 90, which is F. And at the 53, D. This one's done. And last but not least, start at the 37. It's D. Go to the 90, C. And at the 53, E. So that's how you do that. Okay, the length of segment EF. EF is 8 units. The length of segment ED is 10 units. Find the length of FA. FA right here. Okay? So, how do we do this? Well, first you want to solve for FD. And because this is a right triangle, you can just say 8 squared plus FD squared equals 10 squared. So you say 8 squared plus FD squared equals 10 squared. So 64 plus FD squared equals 100. Subtract 64 to both sides. You say FD squared equals 36. So FD equals 6. Square root of both sides. Square root of 36 equals 6. So FD equals 6. All right. Now, we got to get these to line up. So shift into green. So remember, we gotta find FA. This should be pretty easy. Okay. This green triangle has to be rotated. So you got to rotate it so the 37 and the 53 line up. Then you're going to have 6 and 8. So 6 times your scale factor equals 8. Divide by 6, divide by 6. Scale factor is going to equal 4/3. Now the 8's going to be right here, down at the bottom. So then you're going to say 8 times 4/3 equals FA. So FA will equal 32 thirds. So FA equals 32 thirds. This is a tough problem. Now, this ABC, just read these. You got to answer these, short answer. Short answer essays. You got to choose which one you want to do. All right, that's the Unit 3 exam study guide. Good luck.